For most of history, technology progressed slowly. People were not designing microchips or medications or even the wheel. For thousands of generations, our ancestors looked up at the night sky and wondered what stars are, what they are made of, what makes them shine, what their relationship is with each other and with us. They were using eyes and brains anatomically indistinguishable from those of modern astronomers, but they discovered nothing about it. Much of the same was true in every other field of knowledge. It was not for lack of trying, nor for lack of thinking. People observed the world. They tried to understand it, but almost entirely in vain. A few centuries ago, a powerful new mode of discovery and explanation emerged, known as science. Its emergence is known as the scientific revolution because it succeeded almost immediately in creating knowledge at a noticeable rate, which has increased ever since. So, what had changed? There are three crucial factors that sparked the scientific revolution. The first one is a tradition of criticism. Before the Enlightenment, it was believed that everything that was knowable had already been discovered and was enshrined in authoritative sources such as ancient writings and traditional assumptions. Some of those sources did contain some genuine knowledge, but it was entrenched in the form of dogmas along with many falsehoods. This changed with fallibilism. Fallibilism expects that even the best and most fundamental explanations contain misconceptions in addition to the truth. So they are predisposed to try to change them for the better. One not only seeks to correct the misconceptions of the past, but hopes in the future to find and change mistaken ideas that no one today questions or finds problematic. It is fallibilism, not mere rejection of authority, that is essential for the initiation of unlimited knowledge growth, the beginning of infinity. The second factor is testability. A scientific theory must be testable, that is to say, the theory must make predictions which, if the theory were false, could be contradicted by the outcome of some possible observation. For example, before the discovery of radioactivity, chemists had believed and had verified in countless experiments that transmutation is impossible. Rutherford and Soddy boldly conjectured that uranium spontaneously transmutes into other elements. Then, by demonstrating the creation of the element radium in a sealed container of uranium, they refuted the prevailing theory and science progressed. The third factor is having a hard-to-vary explanation. So this is a decisive factor. Testable prediction had always been quite common. Every would-be prophet who claims that the sun will go out next Tuesday has a testable theory. So does every gambler who has a hunch that this is my lucky night, I can feel it. Consider for a moment the ancient Greek myth for explaining the annual onset of winter. Long ago, Hades, god of the underworld, kidnapped and raped Persephone, goddess of spring. Then Persephone's mother, Demeter, goddess of the earth and agriculture, negotiated a contract for her daughter's release, which specified that Persephone would marry Hades and eat a magic seed that would compel her to visit him once a year thereafter. Whenever Persephone was away fulfilling this obligation, Demeter became sad and would command this world to become cold and bleak so that nothing could grow. That myth, though comprehensively false, does constitute an explanation of seasons. It is a claim about the reality that brings our experience of winter. It is also testable. If the cause of winter is Demeter's periodic sadness, then winter must happen everywhere on Earth at the same time. So why is that myth a bad explanation? Because the myth's details are barely connected to the details of the phenomena. They are, in other words, easily variable. In Nordic mythology, seasons are caused by the changing fortunes of Freyr, the god of spring, in his eternal war with the forces of cold and darkness. Whenever Freyr is winning, the earth is warm, and when he is losing, it is cold. The Persephone and Freyr myth asserts radically incompatible things about what is happening in reality to cause seasons. Nothing in the problem of why winter happens is addressed by postulating specifically a marriage contract or a magic seed, or the gods Persephone, Hades, and Demeter or Freyr. Whenever a wide range of variant theories can account equally well for the phenomenon they are trying to explain, there is no reason to prefer one of them over the others, so advocating a particular one in preference to the others is irrational. Theories that are easy to vary in their details are bad explanations. Being proved wrong by experiment and changing the theories to other bad explanations does not get the holders one jot closer to the truth. Now, consider the true explanation of seasons. It is that the Earth's axis of rotation is tilted relative to the plane of its orbit around the Sun. Hence, for half of each year, the northern hemisphere is tilted towards the Sun, while the southern hemisphere is tilted away. And for the other half, it is the other way around. So whenever the Sun's rays are falling vertically in one hemisphere, thus providing more heat per unit area of the surface, they are falling obliquely in the other, thus providing less heat. That is a good explanation, hard to vary, because all its details play a functional role. The axis tilt theory also predicts that the seasons will be out of phase in the two hemispheres. So if they had been found to be in phase, the theory would have been refuted, just as in the event the Persephone and Freyr myths were refuted by the opposite observation. But the difference is, if the axis tilt theory had been refuted, its defenders would have nowhere to go. No easily implemented change could make the tilted axis cause the same seasons all over the planet. New ideas would have been needed. It is only when a theory is a good explanation, hard to vary, that it even matters whether it is testable. Bad explanations are equally useless whether they are testable or not. So how do you get that good explanation? Explanations have to be guessed, then criticized and tested. They are conjectures that are the products of creative imagination. But the problem with imagination is that it can create fiction much more easily than the truth. Inventing falsehoods is easy, and therefore they are easy to vary once found. Discovering good explanations is hard, but the harder they are to find, the harder they are to vary once found. In conclusion, we have seen in this video the three factors that sparked the scientific revolution: a tradition of criticism, the testability of the theories, and most importantly, having hard to vary explanations. This is how we understand that the glowing dots in the night sky are stars, spheres of incandescent gas millions of kilometers in diameter and light years away from us, and that the sun is a typical star and looks different from the others only because we are much closer to it, though still 150 million kilometers away. Yet even at those unimaginable distances, we are confident that we know what makes stars shine. They are powered by the nuclear energy released by transmutation, the conversion of one chemical element into another, mainly hydrogen into helium. We also know that the universe is expanding and began 14 billion years ago with an all-encompassing explosion, the Big Bang, and that the whole universe is just a sliver of an enormously larger entity, the multiverse, which includes vast numbers of such universes. The physical world is much bigger than it once seemed, and it is also immensely richer in detail, diversity, and incident. Yet it all proceeds according to elegant laws of physics that we understand in some depths. So what is more awesome, the phenomena themselves or the fact that we know so much about them? Behind it all is surely an idea so simple, so beautiful that when we grasp it, in a decade, a century, or a millennium, we will all say to each other, how could it have been otherwise?